Good morning, good afternoon. Thanks for joining us today for our webinar, Three Proven Software Quality Imperatives for Digital Transformation. We really appreciate your attendance today. Today is going to be a little different. Good news is it's not going to be a whole lot of slides. It's going to be a discussion. And I think it's very timely because we're going to kind of do an end of year wrap up. We're going to look back at the year and look at some of the key trends that we have seen in the industry, how it relates to some of the big digital drivers that you are all are facing each day from an initiatives perspective and challenges perspective, and then we're going to relate it back to quality. And the other good news is, um, I'm not the one that's going to be from my brilliance, right, going to be sharing with you. But we have a panelist, Arthur Hicken, who's our evangelist. I'm going to bring him on in just a minute as well. But he's been around forever, is a wealth of knowledge, and we're also going to be drawing upon examples that our customers gave us at a recent summit. And so we'll highlight that summit and invite you to go listen to some of those sessions as well, if you didn't catch them already. But so let me go ahead and continue and advance. You'll see I'm doing this a little different because I want to stay on camera. So my slides are sort of in the background. And so let me advance the next slide and talk a little bit about the agenda. Again, I'm going to do a quick intro. I'm really just going to kind of relate, again, kind of relate how the key trends in the industry and digital and transformation relate back to software quality. I'm going to look at a couple of different articles and reports to kind of make that point, and then we're going to pick up on three sort of key items, and one of them is about shifting security testing left. So shift security left in the testing, and why that's super impactful. And for your organization, could be something, again, that we've seen some leading organizations do this year and get huge value. Two, we're going to look at kind of the complexity and of the application development today. Cloud hasn't made things easier. Microservices, architectures, and so forth hasn't made it easier. And so, how do we simplify the testing of those applications with service virtualization? And then the third area is automated testing. We have to automate, number one, but it has to integrate into your existing CI/CD tool chain. As 99% of the organizations out there have shifted how they do development to a more agile, adopted more of a continuous way of developing and delivering software. So with that, I'll do just a quick intro. Swap my slide. So I think first of all, if this isn't clear to you, digital transformation is powered by software, right? So we're going to talk about software. That's my favorite topic. I think ever since I was a kid, software has intrigued me. Is super powerful, and I think I understood this before I could articulate it, or we heard it or saw evidence in the world that software really is shaping the world we live in. But if we take a look at the last year, there's some really interesting themes. First of all, I'll draw upon a Forbes article which calls digital transformation has fundamentally changed the role of software. What's really interesting about that article, and you wouldn't get it from the title, but that security is actually has to be baked in. We have to fundamentally think about securing applications differently. A lot of the trends in software actually create more risk from a security perspective. So if you think about the trend, I mean, just take a very simple trend, cloud, right? As soon as you said, "Hey, Mr. Bank, let's move everything you have out into a public cloud," right? The bank's going like, no, we're fine being a bit of a laggard. If cloud is what's cool and cutting edge, right? You know what? We're good. But it's happening, right? It is happening. But at the same time, there's exposure, and we have to take it into account. But security is a huge theme, right? A huge concern. We'll talk about security in not just the example I gave, but more broadly about there's some interesting trends around security or compliance as code, and so we really need to address that. The second thing it's kind of interesting is we see, this kind of an image here and a quote. There was a series of blogs done, and in that series, it was really all around quality testing, defects, how to improve our ability to find and fix defects. But this person that wrote the blogs, um, Wojtek, uh, is the guy's name, and I can't pronounce his last name, so I apologize. But he interviewed a whole series of individuals. One being this person quoted here. You may or may not be able to see that, but it's Charity Majors. She's the CTO of Honeycomb, and this quote I think is really impactful. I'm going to read it. It's mind-boggling to sit back and actually think about how complex these systems are. What amazes me is not that things fail, but that more or less things work. You have 10, dozens, hundreds of far-flung services, making it exponentially harder to diagnose problems. And so I want to kind of pick up on that exponential complexity. And specifically, what she's talking about, what's making things more complex, is you take a monolithic application and you break it up into a bunch of services across a whole bunch of different applications that are really exposed as through APIs, most typically, right, as a set of services that you can use. And there's a lot of huge advantages to that architecture, right? But on the other hand, there is some complexity, especially as you start thinking about those services being both internal, external. Some represent data or databases. Some, now you have a whole bunch of other things to think about. And then they're all evolving and changing, and you're releasing new software or versions of that software. There could be dependencies you're depending on, and how do you even test that before you get into production, right? It's super complex. So we'll talk a little bit about that. And then the third kind of trend that we see, and this is evidenced in this Forrester Tech Tide, but and the reason I bring this up is this. I've brought this up in a couple other talks because I think it's interesting. The Forrester Tech Tide is on continuous software delivery. It has nothing to do, not nothing, but overtly, it's not specifically focused on testing or quality. It's literally all of the key technologies involved, right, in ensuring that you can move to a more continuous delivery of software. And like I said, I think if I said, hey, are you moving to a more continuous integration and delivery of your software? The answer overwhelmingly is yes, right? You're moving that direction. You've already maybe already there, but you're continuing to work on that tool chain. You're continuing to automate, create more efficiencies, right? And what's really interesting about that particular paper that they wrote is that Forrester, basically the key takeaway number one is that testing tools must be a key area of investment to achieve continuous delivery, meaning there's some definition. Just delivering anything isn't good enough. You have to deliver. There's some level of quality, compliance, security that you have to achieve. And so if you want to do it continuously, you're going to have to invest. And there's 6 actually. If I said, okay, well, how many areas of testing are you investing in your strategy? Most people wouldn't say 6 areas, but there's 6 distinct areas of technology that Forrester calls out. And so I think it's kind of really interesting. And the common thread through all of these, though, is the way we think about quality is we think about quality from a continuous perspective. And notice I didn't say testing, although testing is a key component potentially of exposing the level of quality. And if you don't know what level you have, it's hard to fix things, right? So you're exposing, right, defects, you're exposing issues through testing, and with the goal to achieve higher level quality. But the other thing about our definition of quality is that we think about quality as compliance being a part of quality, safety in the embedded world as being part of quality, security as being a part of quality. So how you define quality is really, really important. Do you have the right definition, right? You could even go so far, we're not going to focus on that a lot here, but I did another talk where I said, another thing is experience. So again, functionally, your application does everything it needs to do. It performs well, but it's a very poor experience for your users. Is that a part of quality? I would say yes, it is. It should be written into your requirements what kind of experience you need them to to have in order for you to achieve your goals for a revenue perspective, from a usage perspective, from an adoption perspective, et cetera. And so all of these things, so I think a lot of people think of quality, they immediately think of web, UI, functional testing. That's what this is all about. And that's, of course, not would be a very simplistic, overly simplistic view. And in fact, I don't even think makes the top 3 trends, because that's what everybody does. That's what they've always done. So as we've always done when we test applications, right? And so that's why we're not even going to focus on that. We're going to talk about other things that are much more value add, I think, for your organization. So with that, let's move on. Let's move. And again, I mentioned this. I'm just going to put this slide up for just a moment. Okay, so short commercial, and the reason I'm putting this slide up here is that you can watch. If you didn't watch our summit, you can do it on demand. But the reason why is because each of the topics we're going to cover, right? You can learn from leading organizations, like the logos you can see on the screen here. You can hear those people talk. So if you don't want to hear Arthur and I talk about how to solve these problems or these themes, but the theme is interesting, you see it as valid, then go listen to somebody who, quote, maybe has more credibility, right? Actual customers talking about their journey, their problems they face, and how they solve them. And that's really what we want to invite you to do. I think you'd learn a lot. It would be very, very complimentary to this discussion. So with that, let's get into topic number 1. So let's talk about shift security left in testing, and why is that important? And by the way, we did in the summit, we specifically had a panel discussion on this topic. I think it was really good. And so with that, I think I'm just gonna queue up Arthur here. I'm gonna put him in the spotlight. And so Arthur, welcome. Thanks for joining us. And why don't you talk a little bit about why shifting security left in testing is important, and not only why it's important, but maybe share some examples of how it makes an impact, and how people can get started.
Matt, we couldn't have picked a more perfect time in one sense, because there are massive security issues in the news today. And I always think, wow, it's amazing. We really timed it right, because we've had this planned for weeks and weeks. On the other hand, if I look back at if we'd done it 4 weeks ago, there were massive security issues in the news. And if we'd have done it, 10 weeks ago, there were massive security issues in the news. And the truth is that, I have all these cool little things that tell me security incidents happening, and they're always in the news. So on one hand, I feel like we hit the timing just right. And the other hand, I feel like it's always the right time to talk about security. And these topics that we want to discuss today, they're all inextricably intertwined, right? The digital transformation that has been, forced on us, right? People talked about it before. People were starting on a multi-year, multi-generational journey to do a digital transformation that, suddenly for some organizations happened in months or weeks. And because of that, we've taken things that were never meant to be exposed to the real world and given them access, either directly, which is scary and madness, or indirectly, but a clever, penetration tester, red team person can dig their way into a mainframe, a weird legacy system, a physical connector in a plant that monitors water purity or something. Everything is now reachable, and that's the real key. That we talk about attack surfaces in security, right? How many places can someone attack me, right? And if you build a big metal safe and live inside it, you have one door. That's it. That's your attack surface. If you live in a house in California, you've got a bunch of windows and walls made out of stucco, which is essentially dried up putty, right? A hammer goes through it. And so as I increase the complexity of my software, as I push it closer to the end users, as I push it more outside of the scope of my little protective bubble, I have to start doing a better job. And the place that people always start with security is like the same place they start with quality. They start at the end. They're like, okay, well, security, I'll do some penetration testing. And that's absolutely an activity that you should do. But what you find if you watch the news, or if you've how many here have installed a malware tool right on their desktop, right? Like antivirus tool, right? It's whack-a-mole, right? You're constantly reacting to and responding. And in security, you can do that. You can spend your whole life playing whack-a-mole, or you can create an environment in which the moles can't thrive. And that's what shift left security is all about. So if you started with penetration testing, then you start to move toward like DAST automation. Can I perform some of this pen testing earlier, and can I perform it on subsets of the application before the whole application is ready? And can I get it in the hands of maybe even down to developers so that we can do some of these activities early? And you'll find stuff earlier. It's early detection, what you're really doing there. But at some point you have to go, I need to make this stop. How can I make this stop? How can I make this one thing stop? And then you look at how you built the code. You look at how you built the application, and you build it in a way that it isn't, weak. And again, I think in a castle mentality versus a house mentality. And I wouldn't think of storing $1 million in my house. It can't be secured. I could spend a fortune testing that it was insecure, but none of that would actually make it secure. And that's where shift left really comes. It's not just earlier testing. That's the first step left. But the next step is, what technologies can we use during the construction phase, during the design phase, that helps us understand? There's a mantra in the aerospace industry around the coding standards they use, and it's using a subset of the language that's safer and more secure and more reliable. And so we use static analysis a lot as an industry to do early detection, to find tainted data paths and software vulnerabilities. But the bigger value, the iceberg under the ocean of static analysis, is enforcing proper coding standards that make you build things right, or disallowing you from doing things that we know will cause problems. There's I don't know, Matt, if you and I have ever talked about this, is if you're a Calvin and Hobbes fan, but I love Calvin and Hobbes, and there's a cartoon there. It's a little kid and his dad and his mom, and they're driving across a bridge, and the kid sees a road sign, and it says, load limit 10,000 pounds. And the kid asks his dad, Dad, how do they know that? And Calvin's dad is awesome. He's always got an answer for everything. And he's like, well, they take trucks and they drive bigger and bigger trucks over the bridge until it collapses. And then they rebuild the bridge, and they know how much it'll hold. And see, like Matt's laughing, you're probably all laughing. And at the moment, that's exactly what we do in software.
That's awesome.
We do it in performance. We do it in security. We build it, we hammer it. When it breaks, we rebuild the piece. We're constantly reacting and responding, rather than, are there known principles? Like when I'm building a bridge, I can predict what kind of forces it can take, what kind of wind it can allow, can it withstand an earthquake, what kind of trucks, how many trucks at once, etc. When I'm building software, can I do that? And the answer is yes, right? And that's kind of the nirvana that you want to get to. You probably start at the right, and you're doing manual testing, and then you move into some DAST, and you move into some functional testing, and then you start doing some kind of flow analysis, static analysis to get it closer to the developer. But at some point, you have to start doing best practices and doing things that are predictable according to what people know will work and what we know won't work. And so I think that's the big
So
value.
I want to dig in on that just a little bit. Because I think, again, our audience is probably varied here, right? There's probably some companies that are less mature, and those that are more mature, and maybe maybe if you work for like a large financial institution, you chances are, right? Again, whether it's deployed, how uniformly across the entire organization is hard to say, but most of these organizations are at least using, a linter. There's something free maybe, or maybe they're using, some other, again, kind of really accessible, simple, low end, SaaS type tool. Um, and I guess, so if you're not, right, that's something obviously potentially to consider. But what's the value? Like there's also, obviously we offer, and there's others out in the market that offer something that's not so not free, um, and it isn't super, you know, it isn't something you just download in 5 minutes and use. But what's the value? First of all, can you talk a little bit about how these tools are actually quite accessible, including, whether it's free or paid, they're quite accessible. Talk a little bit about that, but also what's the value of actually looking at and investing in, a static analysis SaaS tool that, maybe something on the kind of parallel or something equivalent to what we offer at Parasoft.
Sure. So, like, I guess the number one thing that's kind of interesting about static and is always fascinating to me is that it is left shifted. It's not, we haven't shifted out to the requirements or the design, but it's a relatively early activity. And the cool thing is that the way that you implement it, it feels very normal to a software developer. We're used to working into some form of development environment. We execute a compiler and it tells us things, right? And we respond to those mistakes that we have until it all works. And static analysis just fits right into that, whether it's, on your desktop and it's part of the process, whether it's part of your CI/CD, it's, part of your automated build structure, whatever it is, it's giving you more stuff that really is the scope of a developer and not a tester per se, but it's the sort of stuff that you're used to looking at. So static analysis is a really good fit for someone who creates code, both from a process perspective and just from a logic perspective. And there's a second value there, right? Which is, we've all seen the graphs, and we didn't put it up today because we've shown it 1,000 times, but there's this shift left graph based on Capert Jones work that shows that, the cost of a defect at one point is, like low, and then it just like it balloons and skyrockets, right? And it goes up by, 500 or 1,000 or 2,000 times the later you find a defect. And so it's cool because static finds it early. So yeah, anything that you can do early on is great because again, it's not about testing the bridge with a bigger truck. It's about doing something you expect the bigger truck to safely pass through. There are a lot of open source tools out there. In the security context, a lot of open source static tools do really good in a narrow area of security. They tend not to do all of it. So I think about maybe the most popular, secure coding standards are CWE, CERT, and OWASP. And OWASP has this thing called the top 10. So you think, okay, I need 10 static analysis checkers. But the truth is that underneath those, they're really broad categories like, you know, don't allow unvalidated input. Well, there's 10 or 20 or 50 reasons why that could happen. And so you have a bunch of things. And if I look at the OWASP top 10, it represents not 10 concepts, but more like 50. And that's where you run into trouble is, am I really doing everything I need to do? And OWASP top 10 isn't meant to be comprehensive. It's a training project. It's where you start. So if your open source static analysis tool does one or two or three of the top 10, that's an awesome start. Now you need to get 4, 5, 6, 7, and eventually you need to move past those to a much bigger thing. CWE has 800 plus items in it. That's the last time I checked. It might be 900 now, right? But it's growing. And so a static analysis tool that does a broad set of coverage is important for you. And the other is just from an ease of use perspective. One of the things that we do that's kind of interesting that I really like is that we work in a standards native format. So, we have static analysis checkers or rules that have names like buffer overflow or read over W, right? Or, things like that, funny little names, and every static analysis tool does. And what we've done is provide a way to use the tool so that those names are mapped back to things in a coding standard. So like OWASP again, right? And if you don't know what OWASP is, go to OWASP.org and check it out because there's your free security training and your free security tools right there. the thing is that if you're working on something and it's part of OWASP A1 or OWASP A2 or OWASP A3, our static analysis checkers tell you that. They don't tell you our internal name. They tell you the OWASP name or the CWE name or the AutoSAR name. So we always work in this standard-centric way, which makes it easy to use the standard as a way to shift to engineering, as a way to shift to the right behavior, because we're now giving you reasons behind what you're doing. And if you happen to be in an audit world, maybe you're doing, taking credit card data, so you need to do PCI DSS, or you're worried about privacy because of GDPR or CCPA, or you're worried about security as part of safety because you do medical devices or have healthcare information. You have these other standards, and you need to demonstrate what you've done to an auditor, like how do you meet this standard? When did you last meet it? What were the results? And we just do all that organically under the hood. And so, we try to make your life really, really easy from an audit perspective and from a, developer perspective. We're really focused on a developer centric standards native implementation.
Okay, that's awesome. And I think that's a really good description. I think at the end of the day, not everybody here, but most people would probably be familiar with, let's say, VS Code, modern, sort of modern IDEs. What's interesting to me is a good IDE is actually doing static analysis
Yeah.
by color coding, by you can set your own standards on how you want to indent the code so it's readable. All of that is to create an environment where you get immediate feedback to create better code, right? Better code, more syntactically correct code. And this is just going to another level, looking at a bunch of other things that you could do better to improve your chances of minimizing, right, threats, etc. And overall improve your quality, right? So just kind of makes sense, and I think it's just an extension of that. And by the way, these solutions, work in should also integrate with modern tool chains and modern IDEs as well. So okay, so let's move on. Let's move on to the next topic. So again, that was kind of one of the key trends. Again, evidenced by that Forbes article that security is a big deal. But the second area that I want to talk about, right, is really this kind of complexity, the growth of complexity, and this is it's evidenced everywhere. I mean, Hello World today could literally, you could run a local, a version local, but a real world version of Hello World in a real enterprise application sort of environment, so to speak, with cloud and data and services and so forth, it would be like spelling the word hello and picking up the word the letter H from one service, the letter E from another service, which, by the way, it is only available in production. You don't really have a version, so it's testing your hello application. You've got to throw it out in production to test it to get the E, and then the L comes from somewhere else because it's actually a database. It's not really a traditional API service. It's there's a database you have to access, and then so forth. So this is kind of how the world has gone. So talk a little bit about this world we live in, and then what we see evidenced, not just from our own experience, but also as we look at our customers, especially, right? How service virtualization is sort of making an impact. I think you probably have some really good stories too, Arthur.
So, yeah, I want to make one thing clear, like, because we use this word complex and we don't always know what people mean by complex. We certainly quantitatively have a lot more code than we used to. 30 years ago, 200,000 lines was an enormous application. And today that's hello world, to use your example. And so we've gotten more of things, but we've also got this complexity that you're referencing, that the application is no longer something that we wrote all the parts of. We're reusing things. Again, 25, 30 years ago, like, reuse was this really interesting topic, and people were trying to figure out, how do we reuse? How do we reuse? And they had these crazy, crazy tools they were trying to invent that would lift pieces of code and put them back into place. Now, in a world with microservices and APIs, like, we're all reusing. We don't even call it that anymore. We just call it use. But we're picking up a thing from here and there. And you talked early on about user experience. Our user expectation is higher now. We don't expect hello world. If you give me hello world as a user, I'm gone. I'm somewhere else because I expect that it says hello Arthur, good morning. It's nice to see you. I'm sorry that it's raining, right? Like we have all these levels of personalization, and so the name comes from a database lookup, right? And the time comes from a local system service from the local machine running the application itself, or from a more likely a JavaScript module in the browser. So we pull their time and not the time of the server. Classic mistake, right? Like telling somebody in Europe right now, like good morning when it's good evening. And then we pull the weather from local weather service. Again, we get their location from the browser, and then we do a lookup against NOAA, and we pull the weather thing, and we throw back the "Isn't it a beautiful day?" And that is our expectation now. We're crazy spoiled, right? Like we want it all. And from an application testing perspective, I don't own your browser. How do I simulate your browser? How do I simulate browsers in different time zones, right? And now I need to have this database, and I need to touch it, and I need to test it without exposing people's personal information, because that's a huge no-no. And how do I, do things in the real world? Maybe you want to do an update. Maybe I want to charge your credit card for telling you hello every morning. And in testing, I don't want to do a million tests that each charge $1 on someone's credit card. That's kind of considered a no-no these days. People used to do that stuff. So as you build the complexity, you're really dragging in these external services, right? And sometimes these services are your own that you've just set up from a different department. And sometimes these services come from, you know, somewhere else, right? Like they're open source services, they're basic cloud things that everyone uses, like, like a PayPal integration, right? Like everybody who sells anything has some PayPal or other types of integrations. And so you don't own these things, and now you want to test them. Can you test them? And on top of that, we were talking about that digital transformation and people exposing new systems. Suddenly there's a mainframe involved, right? Can you go tell your boss you need a second mainframe? No. Can you tell PayPal that you're going to be charging off $1 million transactions on a regular basis, or that you're going to load test PayPal because you're trying to load test your application? You can't do that. So, and again, the number of dependencies in a modern application is big. It's not two or three or four things. It's 10 or 50 or 100 or 1,000, right? There's so many little pieces. So the cool thing is there's this really weirdly named service virtualization thing that lets you cut the cords to all these things. At the end of the day, everything on the internet talks to each other. And I think it's a really useful metaphor to recognize that it's just talking. You send a message to a server and say, hello, I'd like to know what the weather is in Des Moines. And it gives you a number, right? And so once you realize that how things communicate, they just talk to each other. If you can simulate that communication, you can cut the cord to that thing. You don't have to know how that thing works. You just have to know that when I ask it for a weather, it gives me back this kind of data, and you can simulate it. And so now you can pull the plug on the mainframe, you can pull the plug on the third-party service, you can stand up a lightweight simulation of something that's not ready yet. You can just build a little responder that'll act like the thing because it talks like the thing. It's kind of a Turing test. If it acts and looks and smells like a duck, then it's a duck, at least for testing purposes. So it's really amazing what you can pull off. And the biggest theme that I hear when we do like these summits and we get to talk to customers and dive into their stories is that the phrase untestable. We have this thing and it's untestable. It's untestable because it's expensive, because we don't have the time, we don't have the resources, the services are out of our control. We're not allowed to abuse them, right? And testing includes abuse. Like we're not allowed to drive a 40,000-pound truck over a 10,000-pound bridge. But with service virtualization, I can do it. I can just do it. And so I think service virtualization is really coming into its own now. It's been a hype cycle item for years, but it just allows me to pull the plug on almost anything that I want to test. And that's great, partly because I can test early, partly because I can test cheaply, partly because I can isolate real problems. But for me, the most exciting part is because I can do bad things, because I can drive a 40,000 pound truck over a 10,000 pound bridge. I can make a piece, of my hospital network act like it's a malicious attacker. I can make PayPal flood my system with giant packets as if it's doing a denial of service attack. So that service virtualization allows you to not only cut the cord, but it allows you to thoroughly test your application with all of the bad things that normally don't get tested.
So it's not, but so that sounds to me like it could also be its own nightmare in some way, shape, or form. Creating this virtual environment and managing it and so forth. But I mean, I can see advantages, but how easy is it to create these services? Doing this.
Yeah, like you can do it programmatically, right? Like let's say that you haven't built anything yet, you've got some API definitions. You can do it in a kind of a TDD fashion, right? Like your API definitions and contracts tell you what the API is supposed to be doing. So you stand up a little listener, it's trivial. It's like writing hello world. And you connect it to a data source. So now you have a spreadsheet or a database, MySQL, whatever, that has a list of inputs and responses, right? And that gives you a simplistic thing. But in the real world, and again, in digital transformation, we're not in greenfield, right? Like everybody's moving something. And the beauty is that that thing already exists and it's already talking, and we can listen to it talking. We can put a wiretap in there, right? And we can record the traffic and look at how it's talking, and use smart tools to create things that look and respond like the things we're talking to. I don't need deep monitors inside of an Oracle server to explain how they access the disk. All I need to know is if I say select name from customers, that it returns a certain format of data, and what examples have been used in the past. And I can grab those and
Yep.
reuse them, and then again connect them to a data source and expand it. Maybe I have 10,000 different varieties of name that I want to check, and I just throw them all into a spreadsheet, a table, whatever my data source favorite is, and then just connect that to the test and let it respond randomly. And I can even easily make it respond randomly, like 10% of the time. Don't give me an answer, right? Like give me nothing. Let's see how the system behaves under failure. So it's having traffic,
That's
having
cool.
an existing service makes it a super simple exercise. Not having traffic, it's slightly more difficult, but you can get started pretty easy.
Yep. Yep. Okay. Great. Um, which brings me to sort of the next topic, and I alluded to this. I'm going to switch to my view here. Um, so I alluded to this topic as well, and talked a little bit about it and this whole concept of continuous. But reality is, right? I think it's pretty safe to say a very, very, very significant percentage of our audience today is doing something regarding agile, CI/CD, right? DevOps, DevSecOps, right? They have some tool chain in place of tools they're using to sort of automate and create a more efficient, more continuous integration and delivery of their software. Okay, it's just kind of the way everybody's moving, and so, how does quality or testing fit into that? And can you talk a little bit about how do we move from just CI/CD to let's add a CQ on the end or a CT for continuous quality or continuous testing.
Yeah, so it's a really interesting thing, because I like to describe, like, a continuous deployment, continuous release as kind of a holy grail. Like it does sound like the perfect place to be, right? Like you've updated the software, you've fully tested it and vetted it, and it's ready to go. Let's push the bloody thing out the door. And we do see, organizations moving to hourly or minutely releases in some cases. Some people have really achieved this. But even if you're not wanting to release every hour, like you just want to release on a regular cadence, and maybe it's once a week or twice a month or something, like the maturity and automation behind that is a huge advantage, right? And here's the problem, right? If I just take whatever I'm doing today and I turn up the speed dial, right, to 11, and I automatically push it out to the world, it's going to be fast garbage, right? Like garbage at speed, right? Like that's exactly what you're going to get. And so if you want to get to a world where you have a good continuous environment, tests are always occurring, you're always ready to go, you have to be able to make a decision. So part of your testing needs to make a very good, reliable assessment of, is it ready, right? Not, is there a bug, which is the initial focus of testing, but is this ready to release? Is it okay to release? What's the impact of my business if I release versus don't release? And on top of that, if you want to make that kind of automated decision, you need to have very good automated testing that understands things like coverage and what change-based, impact-based testing and things like that. But you also need to have good assessment tools running early on that tell you, hey, this code, don't even start the test cycle. Like, you need to get this code right first, then start the test cycle, then start the security cycle. So, it's interesting. The talk that Danny did from Woodman, talks about maturity, right? To get to the CI/CD world, there's no single tool you're going to buy that's going to put you there. There are a sequence of things that will enable your continuous journey, but ultimately, you've got to shift all the way to the left. You have to build the best possible product that you can build, that it's safe, reliable, high quality, going to delight your end user. And then you have to have testing that lets you know and understand that it's going to work. It's not going to be unsafe. It's not going to be unpleasant. It's not going to leak the person's user data or DNA data or whatever it is. It's going to give them a good time and a good experience. And then at the end of all that, then you can start your continuous journey, right? Otherwise, again, it's just, garbage at speed.
Sorry, I was like everybody else
You're
searching for
frozen.
my mute button there for
Yeah.
a moment. So yeah, so I think what's interesting, you bring up Danny's talk from Woodman Life. So I think again, I highly recommend that specifically. Again, it's on demand on our automated software testing and quality summit. But it was really interesting because what he wrote, and he wrote his own sort of abstract and what he's going to talk about, right? And he said transitioning from an agile development process with waterfall testing to a full CI/CD methodology with testing integrated throughout the workflow, right? So that's how he described it. And he doesn't just describe it, he describes the value, right? So what are they going to get? They're not just doing this for fun because it's cool, right? They're actually doing it because there's huge value. And I think that's the key, is like, we want, we live in sort of an instant gratification world to some degree, and so we want everything to happen quickly, and we want it to be perfect, and we want, as I think you were talking about users, if they get hello world, that's no good, right? It's like, no, 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 I want the personalized version with full weather and everything else attached to it, and I want it now. And if it doesn't happen, you can forget about it. And so that actual is really interesting, because when developers apply that to the code they're pushing out, they're actually they're actually saying, you know what, Mr. Customer, you can deal with lower quality, lower performance, a worse experience, because I want a better experience in my development of the code, right? Nobody probably thinks about it that way, but that's actually what you're saying as a developer or an organization that develops software when you say, no, we have to push this out quicker. So it's kind of funny because I hear, because we're moving to kind of our theme, our theme for 2022 is going to be along the lines of deliver with confidence, right? So you were talking about that as you were talking about the CI/CD and what you're delivering and what we're adding in. It's confidence. Now you're going to hear from everybody else in the quality and testing world, because they feel like they're forced into it. Oh, we'll accelerate. We'll make it faster. We'll make it, okay. Well, that's interesting. I would make an argument that, the first release, when you implement new processes and new tools and new methods, right, to improve your quality, There's no way on earth it's going to be faster than your last release. That's not going to happen. Now, that being said, if you take into account the technical debt you're dealing with later on, the risk of all the other implications and costs and so forth, and risk that you could incur by not putting out the highest quality, I guarantee you that by the second or third release, if you look at the total time spent, right, you could be way, way ahead of the game by actually implementing some of these practices. But you want to do it practically, right? Obviously. So I guess last question to you, Arthur, and then we'll get to see if there's some questions from the audience. I think we're going a little longer than I thought, so we might cut that short. But if you do have a question, by the way, right, type it in. Type it in now. But here's a question that I think is kind of an obvious one, which is, okay, so what's the practical advice on how do people get started that have this, maybe they have agile development but waterfall testing.
Yeah. So for me, if you're greenfield,
Okay, so I'm going to go ahead and close out. I was talking for a moment there on mute when Arthur's environment crashed. Um, so let me close today's by saying thank you for your attendance. Thank you for your attention. Um, I think reality is any question you might have at this point could be answered pretty easily by attending um, and by okay, looks like I'm getting some conflicting messages of whether I'm actually live. So let me just double check with somebody to make sure and see. Really quickly. Okay, so I am live. Okay, good. I just want to make sure Bright Talk didn't crash as a whole. So it's hard for me to tell. It looks like it's up and running. So okay, so anyway, all the questions you might have, again, I think it could be answered pretty quickly by watching some of the sessions from that automated testing and quality summit. Again, we highlighted a few of those sessions and the topics there and how they relate back to key trends in the industry. So hopefully this was valuable and useful. And have a fantastic day. And again, check out parasoft.com and the summit. All right, thanks.